EVM stateful precompiles. Saying in other words is just how to enable new functionality at your virtual machine level for your own blockchain to be customized to specific use cases. So before we start, and probably, can someone help me with the, yeah, there we go. Okay, so before we start, it's great to have like a common background on what a blockchain virtual machines are, and also a subnet, which is a concept in where Avalanche you can launch your own chains, and this will be important in the context of stateful precompiles, because in order to have a precompile, you will need to have your own chain or make the whole network to accept your precompile. We'll get into that in a minute, but how we can see blockchains is like a replicated state machine, which means that you start with one state, call it, for instance, the different balances that you may have, the different accounts that you have active right now, whatever the state of your blockchain means. And it goes to another state through a state transition function that is being registered in your virtual machine. So the virtual machines define this logic on how we are going to transition from one state to another. In the context of blockchain, this is a block. So each time you add a new block, you change from one state to another. So you can think of virtual machines to be some sort, like for those that are familiar to object-oriented programming, you can think of these as classes and instances. So in the same way that you have objects and classes, or in the same way that you have a virtual machine, you can have an instance of that virtual machine, which is a blockchain. So let's say you have the EVM, which handles all the generic logic of the virtual machine, and then you have the instance of Ethereum mainnet, the instance of the Avalanche C chain, and you can have as well subnet EVM, which enables you to create subnets or your custom chains powered by the EVM. So when we're talking about customizing the EVM, first we need to abstract what the EVM is in the different layers of how blockchain works. So we have the case of Ethereum, where you can have the network level or the consensus level, and then we have the execution level. So the execution level is going to tell us, like, what are we going to change? The consensus level is going to make sure every node has the same execution, the same execution steps, so we all have the same state. And at the very top, we have the solidity or application layer, where we are deploying, as a developer, you mainly interact with this layer, but you can also interact with the different layers behind that. And when we see, for instance, the Avalanche blockchain, you can have the peer-to-peer, the consensus, and as well you have the execution level, where you can launch different subnets, each of them having their own execution environment or their own virtual machine. And on top of that, you can, at the application level, can do whatever you want. You can have some EVM where you write in Solidity, some WASM VM that you can write in Rust or whatever. You can have some virtual machine that uses Move, or you can even have like custom virtual machines. But for this workshop, we're only focusing in this specific part. So it's not like building an application, what we're doing today. It's just modifying the interpreter of the EVM so you can have specific functions associated to execution environment. So basic of the EVM, so in order to go from one state to another state, you can have different kind of interactions. So you can have an external loan account interacting with another external loan account, such as sending just balance of the native token, right? You can have interactions between contracts and contracts calling other contracts as well. The thing is, for this specific case, we will be focusing on contracts. And one thing to have in mind is, even though the EVM is Turing complete, you cannot do, or it's going to be super hard to start doing complex computations. And it's going to be expensive. So it's easy to create just simple computation, assign some memory storage for creating different tokens, managing balances, that kind of thing. But when you're trying to create like linear regressions, machine learning models, like even more complex computation, is going to be hard and it's going to be expensive. So, for instance, if we want, it's not only the computational thing, it's also when you're building in Solidity, you might face some limitations. For instance, the lack of libraries. And this is something we're going to be solving with precompiles. So for instance, one thing that you can use this for, and something that precompile is activated actually in Ethereum for, is for cryptography. It's never a good idea to write your own algorithms for cryptography. So one good thing, and something that is already battle tested, is probably not out in Solidity. So one thing that you can think of how you are going to build your application is not going to the application level, but to the virtual machine level. And so the precompile, you can see it as like Go code wrapped in a Solidity interface. So this is going to make it even more efficient. Solidity is actually a language that has a lot of flaws, and Go is a little bit more battle tested, has a lot of libraries. So if we can see like the different benefits of why doing this, is a lot of it has to do with performance. It's performance. You can use existing libraries, which is really nice when you want to create a specific things for, let's say, zero-knowledge proofs. You don't need to go and reinvent the wheel on Solidity, but you can just take what it's already built on Go and just implement it in your precompile. It will give you more security. You will have more advanced functionality, and it's going to be great. So another thing is like for interoperability to verify data on communication primitives. This is something that we actually use as the precompiles to communicate different chains that they are not EVM. So if we have some way to decode and encode data from one chain to another, we will be able to start communicating to chains that doesn't even have the same execution environment, such as the EVM. So that is actually what happened with Avalanche Warp Messaging, if anyone wants to go deeper into that. But for now, just think of the precompile as this wrapper on some Go implementation. Something to have in mind as well is that precompiles are not at the bytecode level. You don't have any bytecode associated to this. You will have you will be modifying the specific code of the virtual machine. So think of it as a shortcut to execute specific functions of your virtual machine. So an important thing is how this works is whenever a precompile is called, this is deployed at some specific address. We will see an example in the next slide. But it gets deployed at a specific address, and whenever this address is being called by any application, the EVM will know it's a precompile and will not load any bytecode. In contrast, if it's not a precompile, then it loads the bytecode and interprets the bytecode. So, for instance, this is the interface that a precompiled contract, not a stateful precompile yet, just a precompiled contract is going to use. And something also important is that you can customize the gas that is being consumed by this precompile. Why? Because this doesn't follow the rules of the opcodes kind of charging of the gas as you do with simple applications on Solidity, but you can specify how much it's going to cost you to call, let's say, a cryptographic function on the EVM. This will make it as well more efficient. And then you have the execution part of it. So this is how, for instance, SHA-256 looks like. It's going to be deployed at this specific address. This is a reserved address. This is why it looks so cool, so weird, because it's not like created in a normal way, but they have some space of addresses reserved for these precompiles. And this is how you interact with it. You just need to import the interface, and in order to start interacting, it's just like a normal interaction with like any other Solidity contract. It just will execute not in the smart contract itself on Solidity, but in the Go implementation of it. So how you create one, and this is a Go code where you can, I don't know if you can see it really clear, but the Go code, you actually import some crypto SHA-256 in the project, which is a Go library, and you can start implementing over here. It is the implementation. So that is how you start doing precompiles as that, just computation. But when we come to stateful precompiles, this stateful precompile actually injects a state. It can actually inject or have some state access to the database that we're working with. So it needs to implement some other structure which has the run function has this precompile accessible state. This is really important, and this is really dangerous as well, because you are giving access to the state of the blockchain to your virtual machine. So this is why you need a network upgrade each time you want to implement this kind of precompiles. Either you need a network upgrade or you need your own chain. And this is why this starts taking a little bit more adoption once we can start launching our own chains instead of trying to customize the general purpose chain. So as the other one, this one also has some gas supplied and some remaining gas after the execution of the precompile. And when we see this element of the precompile accessible state, you can see that this gets the state database, and this is the part where you will be able to start changing the different key values on your database. So yeah, behind that, all that is just key value pairs, where you can, each key refers of an address of a contract and the value you're going to be changing. And it also all hashes in the value side of the key value pairs. So what kind of different precompiles can we see that make sense, stateful precompiles? Because these now is not only computation, but you can also start writing into state. You can say, for instance, I want an allow list for who can transact in my network, making the chain suitable for permission use cases or more private use cases. Instead of blocking or having the allow list at the application level, you can say, like, I don't want anyone to deploy, I don't know, a marketplace or an NFT on an institutional chain that doesn't have anything to do. So you can leave that everyone, like, let's say everyone can participate, but not everyone can deploy a contract on the chain. So that way you can restrict how the block space is going to be used for your specific application. Another thing that we can have is native minter. This is really nice when we're trying to build cross-chain applications, especially when we are trying to use some native token that represents another native token in another chain or any other token. So for instance, if we are talking about the subnet that wants to use, I don't know, USDC as a native token, as a native gas, you can actually set the native minter of the native token to be the bridge contract. Of course, this has some implications on how this is going to, you need to make sure that contract is audited and in order to actually mint those tokens natively correctly. Also, another thing that you can do is creating a smart contract or a precompile that handles all the fee configuration. And this is great, for instance, when you are, want to, let's say, reduce the gas fee or the gas price that you are paying, minimum gas price on each transaction. Before this precompile, you will need to go for a network upgrade. But if you activate this precompile, you can say that a contract is going to handle it. Of course, these contracts will have an admin, and you can do it however you want. But this allows you to customize the execution layer of your blockchain without needing to go at an application level. So all this happens, and how you configure this kind of precompiles is on your Genesis block. The Genesis block keeps track of where is this going to be activated, because some precompiles could be activated at the very beginning, some others need to be activated as an upgrade. So if you're going to activate that as in the very beginning, you will need a precompile. You specify the address, and you will be able to start interacting with the Solidity interface as I just showed. If you want to go deeper, because this is not like a super long talk to see how you can deploy your own precompiles, this is actually Go code. We have in here an academy that you can check out. So basically, it will allow, we created something that we call the precompile VM. This precompile VM allows you to only focus into the precompile part. You don't have to, it abstracts all the complexity of the subnet EVM or the EVM as a whole, and it will allow you to only deploy this. So basically, if you want to see how the steps look like, of course, we're not doing it today, but you just need to clone the repo, and you create a Solidity interface. This Solidity interface is how you will be interacting with it from another contract. And this Solidity interface is just like as simple as any interface that you have seen in Solidity before. But once you have the Solidity interface, you can compile that, and then you can create, we have this generate precompile SH that is super helpful for you to create all the boilerplate code that you will need in order to generate this precompile. And now you need just to fill out the logic of how your precompile is going to work. There is where you start putting the functions or the libraries from Go, either the SHA-256 or different cryptographic functions, different kind of logics that you can put there. I've seen a lot of hackathon projects including functionalities for zero-knowledge proofs. So yeah, you can import there the thing you're going to do. And then you need to specify, when you're building a virtual machine, you need to tell this virtual machine what plugins or what precompiles are you activating. So you just modify one file, set the reservoir you're going to be using to activate, and you complete the module.go, which is a file where you specify the address that you're going to deploy to. So you just need to make sure you're not using reserved addresses for another thing. Or you cannot have two precompiled with the same address associated to them, because if not, it's going to fail the build. You just build the virtual machine and start the network. So yeah, that's it. You can run a network as well, just test it out, see how it works. And we do have in the academy that I just show, someone missed it, here's the QR. You will find different exercises from doing computational precompile just to generate different cryptographic functions, up to creating a allow list or anything that just start touching the state of your virtual machine. So thank you so much, everyone. And if anyone has any doubt, we can happy to talk after I go step down.
Thank you so much, Andrea. Everyone, if you want to learn more about the topic, don't hesitate to consult the Academy. They're here for that, and they'll be more than happy to give you more information about the shortcuts on EVM. Thank you so much, Andrea. So now for our next talk, we'll have Murat Akdeniz, the founder of Premev, who will join us, and he will be here to present pre-confirmations on mainnet. No. Yeah, there's a mix-up.
I'm happy to present my topic. I've got a confirmation at the Neptune Stage.
Well, well, there's a mix-up, so I will need to leave the MC to the moderator.
No problem. Hello, everybody. My name is David Snyder. I'm one of the co-founders at Lit Protocol. Not sure what happened with the mix-up. And today, let's see if we can get this up. Awesome. Today we're going to talk about account-based solutions to Web3 UX. And I'll define that as we go. So here's our agenda. First I'll tell you about what's Lit Protocol. Then we'll talk about some of the current problems as it relates to logging in and signing up in Web3 today. And then talk about what does the open network solution look like. And then, yeah, if there's any questions, happy to take them. So Lit Protocol is a decentralized key management network. It combines two security technologies. One is called multi-party computation threshold secret schemes. That is a method for taking a private key and dividing it up into a bunch of parts or shares that live across this distributed network. This is live today as of 3 weeks ago after 3 years of research and development. And then the second security level here is that all of the operations for that key share run inside of secure encrypted virtualization. And so this is the security model of defense in depth. And that secure encrypted virtualization is a type of trusted execution environment. You could think about it as a secure computer or a black box that the node operator can't get into. And so with this two-tiered model, that's how collusion is prevented. And of course, it's a key management network, so the two fundamental features of the network are signing things, like signing a transaction, which we'll talk about today in the context of users and wallets, but the network also supports rules-based encryption for data marketplaces and licensing and user-owned data. And so how it works specifically is lit is a key, and each of these nodes, as I mentioned, has these two security components, dividing up the key, running it in the TEE, and then developers can articulate programs in JavaScript that dictate how this decentralized virtual key will sign and encrypt anything. And as you can see, there's a bunch of standard Web 2 style authentication methods that are hooked up to this. And so as a distributed primitive that's relatively new and kind of a first of its kind, we've seen just an explosion of application types. Everything that you see on this list, there's one or more venture-backed teams building these types of products using lit in some capacity. And here are some of the brands. And if you want to talk about any of these use cases after this talk, I'll be around. And at the end of the day, despite how sophisticated and complex the tooling is, what really matters is making the product easy to use. So that's topic one, what we've been doing at Lit Protocol and decentralized key management. Now let's talk a little bit about Web3 UX. So right now, if you want to make the claim that you have one login for the entire internet, which is kind of the dream of Web3, there's basically only one option that you have, which is you have to know where your key material is, likely in the context of self-custody using wallets like MetaMask or your Ledger. Then there's also an emerging market for wallet-as-a-service providers that are selling a SaaS module for creating accounts and logging in. There is, I think, kind of a nefarious thing happening in that industry, which is some of those vendors are claiming we have universal portability, but if you read the fine print, it's only portability across applications that have installed their specific SaaS app. And frankly, this is an untenable future where people have to have different interactions with dApps depending on the vendors that they use. So it really prompted us to start thinking about what is the open solution to this kind of portability. And one more information as it relates to prerequisites before we talk about what the solution. I'm sure you all have familiarity with what a crypto domain is, alice.eth. You can see a couple vendors listed here. But functionally, all of these vendors, and there's many more doing crypto domains, have two things in common. One is an on-chain registry associating the human readable name, let's say alice.eth, with the wallet address. And that is the thing when somebody types alice.eth into a wallet, that gets looked up and goes, okay, where should we actually send these tokens? 0x, so on and so forth is there. And also these smart contracts that manage these names have a place to write metadata. So just arbitrary data associated with that account. And so the big insight here is let's combine these two things together. Essentially taking a crypto domain like alice.eth and combining it with a key to create what is the ultimate Web3 account object. And the standard name that we've been talking about, and we'll be putting forward a CAPE, a chain agnostic improvement proposal, together next week, is login with name. And I'll take you through the user flow as well as how it works as a standard. So the user flow is really quite simple. Somebody clicks login with name on one of the login modals. Then they are presented with the authentication challenges, just like logging into any Web2 website, and then that's it. They're logged in. Depending on the KMS provider, the key management system being used here, there may be some details to figure out whether or not there's a secret stored on the user's device or not. In the case of Lit, that there's not, which is helpful for portability. And now let's talk about how this works. So the insight here is in that metadata field of the crypto domain, writing the key management provider there, such that the user, Alice, when Alice enters alice.eth into the modal looks up on chain and goes, who's got the key for this name? Then that key management provider is notified and says, hey, alice.eth is trying to log in here. What is the authentication material associated with Alice? Let's say for the sake of example, it's sign in with Google with a 6-digit authenticator, Google Authenticator style code. Those get served back up to Alice. Alice clicks login with Google, enters her 6-digit code, which in turn, she's now completed the authorization and the authentication, with the key management provider. And so the signature is generated and Alice is logged into the dApp. So the state of development of this today is we should have a live demo of this in a week that is using lit keys and the WAGMI React kit. There's a chain agnostic improvement proposal going up soon. And a lot of our collaborators around this cape are the folks from EIP 7555 that are thinking about single sign-on and authentication. These two things are going to work together. And I think the future is really bright because we now have this really coherent idea of a Web3 account that you can log into accounts with, you can receive messages at it, you can receive money with it, you can send money with it. And the fundamental idea here, now that we are in a space where there are third-party key management systems like Lit, and I'll mention more about that in a second, is that the user is functionally logging into the domain using the Web2 style authentication. And then the domain, because it has a key associated with it, is logging into the dApp. And this is, I think, like a much better way for managing portability and making it open and universal than we have today. And as we think about, okay, what key management vendor should be used here, some of the benefits of using Lit, this distributed key management network running the MPC TSS inside of the TEEs, is that you get full portability because there's no secret stored on the user's device. There's no centralized controllers. This is a distributed network. As I mentioned, we just launched with mainnet 3 weeks ago after 3 years of R&D. Currently, it uses a testnet token. That'll be changing later this year. Social authentication, multi-factor authentication. One of the other really interesting benefits around having the key material live inside of a network is being able to add all kinds of automation. So there's an application called Telefriends, which is an in-Telegram wallet app where users can opt into automated copy trading, where they can say, I want my balance of my wallet to look exactly like this wallet, and they can be totally no human in the loop. They could be asleep, they could be at the bar, they could do whatever. The signing is happening in an automated way because what Lit functionally is a key management service where you can write serverless functions that dictate how the distributed key will sign and decrypt. And then one of the other benefits here, as this starts to become fully realized, is this also becomes a mechanism for abstracting the bridging of assets across chain and the chain selection away from users that can move into the background. And then also mention domainwallet.id. This is the crypto domain project that we're playing with, where any given brand can essentially become a registrar of these type of domain wallets, functionally what we're talking about here, to any arbitrary customer that they may have. So for example, MrBeastFanClub.com could provision alice.MrBeastFanClub.com, and that name, alice.MrBeast.fanclub.com, becomes one of these kind of domain wallet or ultimate Web3 account objects that we're talking about here, combining the functionality of a wallet with a crypto domain. And then this is my last slide. Just to kind of zoom out here, this is obviously a deep dive into a specific user experience standard and convention, but just want to mention a perspective that has been really alive for us over the past 3 years in building out this key management network. which is that one way to think about the revolution that is afoot is certainly through the lens of digital assets and blockchain. But my invitation to you is actually to even broaden your view of what Satoshi did. And if you go back to the white paper and look at the first two sentences, the first sentence is, we need peer-to-peer cash. I'm paraphrasing here. The second sentence is, digital signatures provide part of the solution, but then we also need a method to prevent double spending. And then the next 9 pages are all about proof of work. And the way that we've really been thinking about what is Web3, what is crypto, what is happening here, in a way is the digital signature revolution, because this encompasses everything happening in digital assets, everything happening in user-owned data, everything happening in credentialing, and it's all made possible through cryptography. And yeah, as I mentioned, LIT is a key management network that's distributed, fault-tolerant, threshold-based, that developers can use to articulate programs for signing and encryption. And with that, here's how to find us. I'll be around right now. And yeah, really grateful that you're here or watching on the internet. Hello, future. Thank you so much.
Thank you, David. And sorry, everyone, for the mix-up. So please, let's welcome on stage Murat Akdeniz, who's the founder of Premev, and he's solving for execution hedge. So welcome him.
Is your team? Maybe, some friends, so. Hey, everyone.
We're just going to have you take a break for a couple of minutes so we could be on schedule with it, but we'll just do a check here. I should just say maybe we start your presentation.
Looks like we're taking a couple-minute break.
Oh, yeah, we just got to plug you in and test it, but just because he went early and just took your spots, we just want to go give you like his exact spot, which I think is like 12:55 or something. Just so we're on time for the stream. Appreciate it. And it's kind of weird. We just want to be as accurate as we can for people streaming it. But yeah, if you want to connect in, we can at least make sure we're getting signal. Yeah. Give me a second to switch it over on his port. Alex, were you able to check this? Okay, cool. Thanks.
Yeah, it's not until 15 more minutes. I think the guy before.
You want to announce that or something? Yeah. Or I can announce it too. Yeah, that'd be perfect, because then we're back on schedule.
So just to inform you, we have to wait until 12:55 for the next workshop. The idea here is just to be on time, like on schedule. So yeah, we'll be starting in 15 minutes. Thank you. Hello, everyone. Happy to be back. So let's welcome Murat Akdeniz from Premev. And this is a workshop on pre-confirmations on mainnet. So he will explain ways to hedge with transactions. So I'll leave the floor to Murat.
Thank you, Ava. Hey, everyone. Sorry for the confusion there. I guess I should have pre-confirmed my slot earlier. No puns. But at Premev, we've been thinking about pre-confirmations on mainnet for a long time. And about a year ago, we got on this journey, and it didn't resonate with a lot of people. First, because it required a lot of understanding of MEV and block building dynamics. But today, I'm happy to say that we're able to achieve pre-confirmations on mainnet, and we're testing them on Holsky. But before we get into all of that, let's go into what pre-confirmations are. So we published a research piece earlier this month that established a definition for pre-confirmations. And we define them as a credible heads up before a confirmation happens. And this definition applies to many things, not just blockchains. So when you order something from Amazon, for example, Amazon gives you a credible heads up before the item is delivered in your house. And that credibility is so powerful that you trust it, and you're better off not second guessing Amazon's heads up that some pack of razors is going to be at your house. And ultimately, you don't care about whether USPS is delivering the pack of razors to your house or somebody else. So we want to achieve the same kind of paradigm on Ethereum and on blockchain systems. So we dive into how we do this. And we define these 4 types of pre-confirmations as transactions, state, block, and slot. So what do these mean? We're going to go into transaction pre-confirmations for the most part in this presentation. However, the others are state, where you claim some state on Ethereum, a block. So you might have a block that might get pre-confirmed by a validator. And then you might also have a slot that is way in the future that you have some rights against, right? So these are how pre-confirmations can apply in different states. But right now we're focusing on transaction pre-confirmations, meaning you have a transaction that you want to get on chain, and you receive a credible heads up from a group of entities or an entity about this. So I gave this kind of Amazon USPS example a little while ago, and it really holds under this condition. And the common thinking around the space for pre-confirmations was that it needs to be delivery focused. Because the proposer has the ultimate monopoly on what block goes on chain or what transactions go on chain, everyone was thinking, okay, we need to enable the proposer to facilitate this somehow. But we have about 1 million validators, so who wants to kind of have the millionth person or want to do a sales cycle to have the millionth validator adopt your solution? And include all of this complexity and kind of these solo stakers and all this world where people don't want to be doing this. Validators just want to kind of stake their ETH and then call it a day. So we introduced these fulfillment specified entities. And right now they're block builders and relays on Ethereum network. So we show that through a fulfillment consortium model and having a network between these fulfillers of pre-confirmations, you can achieve similar results without validator participation. And the fundamental problem today is that there's no known execution risk on Ethereum. What you do is you send your transaction, and a group of block builders, relays, validators, decide at the end of the day that it lands on chain or not, and you find out 15 seconds later. And through this time, you have no idea what your execution risk is. So this fulfillment consortium model, where you have the different block builders on a network, allows you to quantify your execution risk. Because if they represent, let's say, 20%, 30%, 50% of the network, you can add them up and get to a level that is satisfactory for you for pre-confirmations. And then your execution risk. In this example, it's 20%, and then you can plug that number into your risk algorithm and hedge your trades or whatever else you have. However, this model gets incredibly strong once you have the proposer commitment as well. So if the proposer said, hey, this pre-confirmation you guys are playing, I will honor this no matter what, then you have the ultimate credibility for your pre-confirmation. So you know that the block builder will be able to deliver that pre-confirmation promise that it gave you in real time. So how do we achieve mem-boost style transaction pre-confirmations? There's 2 key characteristics here. One is you need a P2P network for fulfillment and delivery. We don't want to deal with single block builders. We don't want to deal with centralized entities. What we want to deal with as users is a network, and we just send it what we want, and the network replies back to us. We don't want to care what this provider or what that block builder or what this proposer says. We want to care what the network thinks about our transaction and our pre-confirmations. The second thing is you need a different chain to play these fast games. And fast games are defined as games that Ethereum does not have by construction because it has 12-second block times. So if you're trying to play these intra-block games, you cannot do them on Ethereum. So we're creating a chain, a very kind of high throughput chain, so that these kinds of pre-confirmation fast games and others that we get into later can be played in. So when you combine these two things together, you get MEV commit. MEV commit is a specialized network that is P2P oriented, it's real-time oriented, and it has this fast chain that can settle these bids and commitments. And this is the first time such a chain or concept is introduced to Ethereum, so we're very excited about what that can bring. Now, we have two things, as I said, but one caveat is that it's an encrypted P2P network because you don't want to be leaking information about what is being pre-confirmed because that can change all sorts of auction dynamics when it comes to MEV. So it has privacy built into this P2P, and then it also has this fast games chain, as I just mentioned. What's different about the MEV commit node compared to traditional blockchain nodes is that it's different per your role in the network. So if you were a bidder and you're bidding for pre-confirmations, you run a bidder node, and that's all you deal with. And if you're a provider of execution services, you run a provider node, and then that might hook into your other infrastructure and your decisioning engines, et cetera, where you can issue these credible commitments in real time. What's interesting about how we've set up this network is that it doesn't care whether you're a proposer or sequencer or block builder or whoever else. It's that you're on a bidder role for someone else in the MEV pipeline, and you're a provider for someone else in the MEV pipeline. And this allows for a host of applications to be developed on this platform. Because basically we cannot even imagine this design space for and what it means for these actors. And the fact that they can coordinate over this network and achieve things on Ethereum makes it super powerful. So we basically think pre-confirmations are a new transaction type. We think it represents net new order flow for block builders, and we think it's just simply new and different than other transactions. And I'm going to go into why. So we came up with this piece of research about a year ago. As you can see, the last time it was changed was 7 months ago. And I had this thesis that EIP 1559, with its gas expression of base fee and priority fee, was not sufficient to really express what you want from the network. And I had this insight, and it was quite controversial. I said, hey, look, you need something better, or you need an improvement on EIP 1559. And I got the chance to talk about this with Tim Roughgarden, who was the game theory professor at Columbia University, who was partially authored, or if not fully authored, EIP 1559 with Barnaby from the EF. And to my surprise, he agreed. He agreed that 1559 had limitations and that such a pre-confirmation bid could augment the characteristics of EIP 1559. So what does that look like? EIP 1559 has these two fields, max fee and priority fee, and none of them are concerned with time or pre-confirmations. What we now add over MEV commit is a third field about your pre-confirmation bid. And as you can see, this is expressed through a transaction hash reference, a bid amount in Wei, so in gas and ETH, and then a target block number that you want this pre-confirmation to happen against. And once you issue this to the network, in real time, providers are able to give you credible commitments that you can use to understand your execution risk and take action. And this concept of decay becomes very, very important. Some of you might recognize this character, which is a goblin banker from World of Warcraft. And the famous quote is that time is money, friend, right? So in the case of pre-confirmations, time is actually money. The amount you bid has to do with the time that you bid it at, and it decays in real time such that all providers are incented in real time to commit to your transaction. Because if you don't have such a decay mechanism, what ends up being is everybody waits till the end of the block and then pre-confirms everything, but that's not useful because you know like 1 second or ahead of time or even less. So it's very imperative. It's imperative that there's a decay mechanism when it comes to pre-confirmations, and it sets the pre-conf bid apart from EIP 1559 or other gas-related bids. Now, how does this work? Well, you send your pre-confirmation bid, and you get real-time commitments. Some magic happens afterwards, and then you profit. Well, let's dive into this a little bit, right? So what does that really mean? Well, once you receive these commitments, the actor that committed to you, the provider, is working to figure to how to deliver this commitment to you, right? And they're going to make some decisions to do that and ultimately opt to include you in their block because otherwise they will get slashed. So that's a whole bunch of kind of magic that happens in between where your intent or whatever is being solved. Right? But at the end of the day, you should get your result most of the time. And in the case where you don't, the provider would be slashed and you would get rewarded funds. So, but in the golden case, if all goes well, your transaction lands on chain, you knew about it ahead of time, and therefore your pre-confirmation bid goes to the provider that provided you this service. Now, we take a different route when it comes to EIP 4844. And this is a very new phenomenon. We have research in this space that is very, very important. Now, we identify blobs as the Ryu character from Street Fighter here, because Ryu has a special power, and I will reveal what that is to you. But EIP 4844 is fundamentally different because it introduces another transaction type, these blob transactions. And these transactions are, one, very, very cheap for rollups to submit their stake commitments, and two, are very, very large. They're equivalent to about the largest transaction on Ethereum. So it goes to, it might raise some questions about, well, why should I add this really cheap transaction that's going to be very, very big and be troublesome? And that is an uncomfortable truth today. Now, what becomes very important when it comes to EIP 4844 is the block latency. Each blob transaction adds a tremendous amount of latency to the block because of the size that it brings on. And we go into this in some charts. Now, this demonstrates how basically blobs might travel to be verified by proposers. And as you can see, they might arrive at different times, and that might be problematic because it can't be verified in time, and then it could lead to a reorg or a missed slot. So what you really want is to have the knowledge ahead of time of what blobs you need to have in your block. And pre-confirmations become very important for that, because if a block builder can tell you, hey, these are the blobs that you're going to need ahead of time, then they don't have to wait for these blobs to travel over the network or anything. They can just send you the block, and you have the blobs. Boom, propose it to the network, everybody wins. So we demonstrate how sizable blobs are compared to the rest of the block. As you can see, 90 or so percent of the time, actually, they take about 90 or so percent of the block in 10,000 plus block counts that we've observed on the whole ski network. So, they take up a lot of the block, basically. This is a similar chart. It shows you what the size difference of a block is with or without blobs. And as you can see, many blocks have lots and lots of blobs, and they add a tremendous amount of size in kilobytes to the block. And this slows it down for propagating across the network. And what's very interesting about EIP 4844 is that there is no direct priority fee mechanism. So you can't actually tip the block builder, hey, here's some extra money, please include my blob. What ends up happening is that the priority fee per gas that EIP 1559 refers to gets stuck inside the type 2 transaction, referring to the type 2 transaction details. And this new field, max fee for per blob gas, ends up referring to what the blob is. But it works more like the base fee rather than the priority fee going to the network over the block builder. Now you can work some fancy stuff and figure out some solutions here, but really the availability of pre-conf bids makes this easy. Just tip the block builder, and there you go, it's pre-confirmed. So we identify blobs as Ryu, and then Mev as Blanca in this case, and Ryu used a pre-conf to meet Blanca. And this is what is going to really happen in reality in EIP 4844. It's not just enough that the blobs are cheap. It's that they have to contend with MEV for block space. And this is an uncomfortable truth today. So you think, oh, well, rollups are going to have access to this cheap data in this field. But guess what? In times of high MEV, they're still going to have to pay the same prices. So in order to basically abstract this concept, we use pre-confirmations so that these timing games related to blobs don't have to be played. KO. We announced MEV commit on Holski testnet. This is available today. It's working. We're very excited, actually. We had a major release go out today that stabilizes the network as well, and we're on our way to mainnet to have pre-confirmations happen on Ethereum. This is our Explorer. It just reset because of the new release, but as you can see, there's a few folks on there testing pre-confirmations, and actually the block builder that integrated is I believe, the dominant block builder on Holesky testnet today. I encourage the audience to check out mevcommit and let us know your thoughts. To summarize, mevcommit is this new fast games chain and a peer-to-peer network for pre-confirmations on Ethereum and many other fast games to come. And we believe this is a groundbreaking moment for Ethereum to present user experiences that are expected in the Web 2 world, such as real-time user experiences. And we believe it also unlocks a new design space for real-time applications to be developed on Ethereum. This is a QR code that you can use to get more information. It has a bunch of links. So if you scan that, you can read more about mevcommit, reach out to us, follow us on Twitter, reach out to me, etc. We're working with block builders, validators, and relays right now. Searchers are already sending bids on the network, but there's a lot of room for all sorts of folks to come, wallets, RPC providers, other protocols to make use of pre-confirmations. Again, this is live today on Holesky testnet and will be available on mainnet hopefully by DevCon in Thailand in November. Hopefully way before that. But yeah, I believe we have a few minutes for questions, so I'd love to hear the audience's questions if you guys have any. But yeah, that's us at PrimeMev, and this is mevcommit. Thank you.
Hello. I would like to know how mevcommit would help to prevent sandwich attacks and stuff like that. Does it help at all, or not, basically?
Yeah, great question, and thank you for it. So we have a spicy take when it comes to MEV protection. We don't believe you can be protected from MEV. We believe it's a fundamental fact of distributed systems and current blockchains. So, and we demonstrate this in our reordering slippage research. If you want to read it, it was published on frontier.tech, where we show that even MEV protection services experience lots and lots of slippage, up to 10% at times. What mevcommit allows you to do is fight fire with fire, which is why it's fundamentally different. It is not protecting you from MEV, but it's giving you the superpowers that you need to beat the other MEV. And you can use pre-confirmations for that purpose, right? So if you're working against some state and the block builder pre-confirms your transaction, guess what? You've won that. And then we're working on other sorts of commitments where you can specify things like, hey, I want to be the top of the block. Hey, I want to be in the top 10% of the block, right? So you can statistically avoid lots and lots of front running in these ways. Now, is it a foolproof 100% guaranteed mechanism? No. It is a social commitment at the end of the day. But it should hold 99+% of the time. And that's way better than where we are today. And that would be real wins and not just some fake protection that you're sold and shown some nice numbers, but then you find out that you experience 10% slippage on chain.
Hi, I was curious, how do you deal with sub-second latencies on the parallel chain that you're using for processing the transactions? I saw the 0.1 second block times, and I think it's a particular challenge to keep track of time with that granularity in a distributed system. Thank you.
Yeah, wonderful question. So that 0.1 second block time right now is basically possible because of its POA chain that's built for high throughput. It is problematic when you try to decentralize that more and more, unless you take some round robin kind of approach, right? We have a innovation here where we're working on adding a timestamp to the bid, and we have a tester on the network that attests to the timestamp that the commitment happened. So the delta between those timestamps ends up being how you want to calculate the decay over the block seconds. So basically, having this abstraction mechanism for time allows you to increase your block times and still be compatible with a fast games mentality. At the end of the day, these are signatures happening over a peer-to-peer network. And yes, they do settle in a chain, but the settlement is not kind of in the critical path for you to understand the knowledge about your pre-confirmation, right? So because of that mechanism and then the decay, we're able to kind of abstract things away from the block times eventually. So we would anticipate the block time to go a little over 0.1 seconds, but settle hopefully somewhere around 0.2 or 0.3, something below 0.5 at the end of the day. But great question, thank you.
Thank you, Murat. Can we show some love to Murat, please? It's been great learning more about pre-confirmations, and I'm very excited about what you're building. OK, so we have a break, 5 minutes, and then we'll be back with a panel. sharding. Yeah, I don't have the topics. Okay, hi everyone, welcome back. So we're welcoming now a panel. So we have Preston van Loon from Offchain Labs and Terence Tsao, also from Offchain Labs. And this panel will be moderated by Christine Kim, who's from Galaxy. And yeah, so we're here to learn more about the Protodank sharding. And the floor is yours. Thank you.
Thank you. Thank you so much, Ava. Is it Ava? Yes, Ava. Yeah, so we're here to talk about the next major upgrade that's happening on Ethereum. It's going to happen in 2 weeks' time, so everybody get prepared about what's to come. I think probably the best way to start this panel is to talk about the main code change that's going into Dencun, and probably the code change that caused the most delays to the upgrade itself. So maybe, Preston, do you want to give first an overview of EIP 4844? And specifically, can you speak to why it was so important and so urgent for developers to prioritize in Dencun and put so much effort into for the Dencun upgrade?
Yeah, sure. So the EIP 4844 is the Protodankdencunsharding, and the main idea for this is to provide another layer of data for things like L2s to submit their transactions and to post their batch transactions. The typical use case we see are these, the L2s will post the data and they only need it around for a short amount of time, maybe weeks or months. So it's ephemeral data and doesn't need to stay on Ethereum forever. And it also doesn't need to compete with the gas market for regular users. Like if I'm trying to submit a transaction on Uniswap or something, it doesn't need to compete with L2 batch transactions that are really not making significant state changes. So what this means is that we've created this layer where we can have arbitrary blobs, arbitrary data that can then be, verified on chain, and that could be some mechanism for, L2s being the primary example of proving something happened or didn't happen, rather, on L2s. And the reason this is so important is we have a roll-up centric roadmap, right, where we're trying to scale Ethereum to make it easier, to make it cheaper for users, and that comes with bringing this data layer for L2s.
Are fees really kind of the main barrier for adoption to rollups right now, would you say? Given that, the reason why we're having new transactions, higher block sizes, a new type of transaction, all of this complexity, for the benefit of lowering fees on L2s. Is that really the biggest kind of barrier to entry for L2s, would you say? And is scalability for Ethereum through L2s, are we sure that that's the end game for Ethereum scalability?
Yeah, I would say it's not just the barrier of entry for L2s, but all of Ethereum. The goal is to reduce fees, or at least increase capacity, right? Because it's a dynamic fee market. The more supply you have relative to the demand, you'll have lower fees. So I think for that reason it is important. I mean, nobody really wants to pay hundreds or thousands of dollars to deploy a smart contract when there's a future out there where it could be less than 1 cent, for example. I don't know that's exactly what will happen with the Dencun, but the fees will be drastically lower, and we should see a lot of, or some movement from the L1 to L2s where things are cheaper, and sort of moving towards this goal of L1 being more of a settlement layer than where we're doing most of the transacting.
Yeah, so let's talk a little bit more about the fee part, because that really seems like the goal, like one of the main results that we want from EIP 4844, from the Dencun upgrade. I have yet to see really any concrete estimations for how much cheaper exactly we're really going to get? It seems like the real answer is we don't know. It'll get cheaper, but maybe between a very large interval of like 10x to 100x. And there might be, we're pretty confident there's going to be secondary markets for blobs, but there hasn't been a ton of analysis on exactly who these markets are going to be run by. There seems to be a lot of open-ended questions of what's really going to happen to L2s and the blob fee market that I haven't really seen developers really care about or explain. Terence, can you explain why that is? Why do we not know how fees are going to be impacted by L2s if this is the point of the upgrade?
Yeah, that's a great question. So,
also, I like your shoes.
Thank you.
They're very nice.
This was actually for your podcast. Just it's supposed to be jungle themed, but yeah. Anyway,
love that.
shout out to your podcast.
Jungle theme.
But so the textbook answer to that question is no one knows, right? But I can give you my more like a math estimation that if today you take the Arbitrum data, you switch from cold data to blob data, it's about 4 times cheaper, right? So you can say at the baseline, everything will be 4 times cheaper. But then again, that's the first order effect. Then there's this second order effect. If today it's 4 times cheaper, then more people will use it. Then it becomes the same cost as before or even more expensive. It's almost like the thermos, right? You put it in your room, you set the temperature to 75 degrees, and then you can go up and down, but eventually it will reach that equilibrium. And today the equilibrium is these 3 blobs per slot. Just if today we have 3 blobs per slot, if it's at 3 blobs or lower than 3 blobs, the price is basically free. So anyone can post anything. It's basically free, right? If today I see the price is free, it's 0. I mean, us like a hacker or someone that's bored, I can just post random data on there. I don't care, right? So you can think of that from that angle. Someone will always do something. So it will always be 3 blobs, right? So now the question is, okay, what happens? What's the second order effect? And today, older layer 2 combined use about 1 gigabyte of data per day. And that's about 1/4 of the whole EIP 4844 blob space. So we have another half to reach before the price increase. And I have no doubt that we can easily reach that.
Okay, as far as says they are, I mean, that is a little bit more clarity, so I appreciate that. But assuming that L2 fees really do come down significantly and become as competitive as, say, competitive alt layer ones like Solana, I don't know, like Avalanche, et cetera, my question is, are L2s really the place where we want to push Ethereum users to go to now, given that the level of decentralization, say security, say scalability of L2s is really not that different from what you could experience on, say, Solana or these other alt L1s that I mentioned? And really, like, the competitive advantage of Ethereum's network effect is that you're able to utilize and leverage the full, like, composable dApp ecosystem of Ethereum. Like, are we really sure that we want to start pushing users to the L2 now with an upgrade like Dencun? Are L2s ready for end users? And are you worried at all that as users move to L2s, they notice that the user experience for this level of decentralization and security could perhaps better be utilized on a platform like Solana?
I'll start with that. I would say that an L2 is only as secure as its weakest link, right? And if you think about a complete L2 benefits entirely from the security of Ethereum. So even if it completely fell apart, you still can exit and complete, whatever you were trying to do back onto L1. So the security is still there, although like that's kind of still like a worst case scenario. So I mean, if it's a true L2, I wouldn't say that you have a less secure environment. I would say maybe you have a liveness risk or maybe a reliability depending on the L2, right? They could go down, but Ethereum doesn't go down. But as far as like security-wise, like if it's a true L2, it should be inherently just as secure as L1 security.
So L2s in their current state, you would say, is competitive against other alternative L1s?
Well, the caveat is it has to be a complete L2, right? You have to have like some mechanism to prove any fraudulent behavior of a sequencer. So you have to have fraud proofs. You have to have all these mechanisms. And I wouldn't say that all L2s have this. I wouldn't even say that any L2 is complete yet, but they are in different phases of reaching that level of security.
Anything to add there,
So
Terence?
I will add. So I will maybe like a little bit more controversial point is that if today we don't have this like scalable data on Ethereum, meaning that if we provide scalable data, then more users might move to layer 2 because it's cheaper. If we don't do that, then there's other DA solution that's coming, right? People will eventually move out of Ethereum anyway to use the other DA solution. But then the downside of that is that, well, you're not settled on Ethereum anymore, and then you're posting DA something else, then the security is worse, right? And then as someone that's working on Ethereum space, I will hate for them to take our lunch, basically, right? So that's something that we have to do something, right? And whether how to do it, like what to do it, like when to do it, that's another question.
Wow, Ethereum competing also as a DA layer. That's another really big topic that, I don't think we have time to get into, but it is a point that everyone should take note of, and perhaps we should do another panel on. Okay, let's also talk about testing for Dencun a little bit, because I gotta say, Terence, Prism was in the hot seat. The Prism team, the client team was in the hot seat for many of these calls. So many client teams on the execution layer and consensus layer were pushing, let's get these test nets up, let's move forward with scheduling the testnet upgrade for Dencun on a certain date. And you were one of the voices, sometimes the only voice, asking for more time, more testing, more review. Let's see how the MEV boost infrastructure is working. And I think in many instances, there were periods where other client teams were kind of suggesting that your team, the Prism team, was the reason that the upgrade was being delayed. Were you feeling very pressured about trying to get all of the code changes that are required for Dencun in a timely manner? Are you concerned at all about the testing process having been too rushed, given just like the amount of how the Prism team was a little bit in the minority this time around for testing timeline and opinions around the testing timeline?
Yeah, definitely. So this is a great question. So I think Prism team was actually the first team along with Lighthouse that had this waiver for interrupt to start with, right? And then between them, we have found like many issues with the spec within the code itself, and then we kind of iterate on those issues, right? And the question was just like, I think this is just expectation, right? Just say we have been on mainnet since Beacon Chain launch for about 4 years now. So would you argue the Beacon Chain launch was rushed, or would you argue the Beacon Chain launch was right on time, right? And to be fair, when the Beacon Chain launch, we probably have like 90% confidence that this is gonna work, but we have to ship something, right? So we had 90% confidence. Then at the merge, we probably had 95% confidence that it wasn't gonna work, but then it went really well, right? But then as the protocol ossify, as the client code ossify, I argue that it becomes very hard to make changes, and that is for the good thing, right? Like today, would you ride an airplane if someone tells you it works 99.9% of the time? Probably not, right? You want something that's perfect, as close to perfect as possible. So we kind of had this mindset we kind of had this mindset baked in our brain as we get towards the mainnet that like we're still finding bugs, the relay is not ready, and then the MEV boost is not ready, and 2 weeks test time is not enough. And typically we do way longer test net time, but this time we only do 2 weeks per test net. To us, that was very rushed, right? I guess it's just managing expectation. If today you say, okay, well, if we're okay with 90% ready, then let's ship it, then sure, we're fine. But we're kind of striving for that 99.99% like perfection.
Yeah, we used to move fast and break things. I think before the Beacon Chain launch, you can look at some of our early testnets kind of crash and burn. And now being in a position where we're one of the 2 most popular clients, we can't afford to mess it up. And our testing internally, we're really, really looking for the bugs and making sure they're ironed out. Because when Prism has an issue,
Ethereum will have an issue, and we're really just making sure that's not going to happen.
I 100% agree with this logic, but it doesn't seem like the logic that other client teams are adopting. Like Prism might have a 95%, are we 95% sure, but it seems like perhaps other client teams have a little bit of a lower bar. And I'm curious to know, like, as the complexity of Ethereum grows, why is it that there seems to be increased pressure to get upgrades out faster? If we're talking about Dencun, the timeline for Dencun, especially the last 3 testnets, there was even talk about, you know, instead of having the last 3 public testnets 2 weeks apart, just like shortening it to 1. The next upgrade, Electra, there's a ton of pressure to get it done before the end of the year. If Ethereum is getting bulkier, more complex, difficult to test, why is it that the testing process, and it seems as though the general kind of feel is to do more upgrades faster, like basically start changing Ethereum, like move fast and break things.
Yeah, I'll start with that. You know, if we were more of a minority client, we could probably YOLO a little bit more. Like, because if 5% of the network goes offline, well, things are not going to be too impacted. And to the point about people expecting things to move a little faster, I mean, we've been hearing this for a while. Like, when merged, like that was a meme for a long time. Like we almost got a little bit like, come on, give us a break. We're going as fast as we can here. We're only human. And yeah, you have a great point about complexity, right? Like now we have 2 layers we have to manage, and there are a lot of clients, and there's a lot of different combination of things that could happen. And there are a lot of sophisticated ideas about like attacking P2P. So we just really, really want it to be robust, and liveness is really important. You know, I just say, I feel like in these instances, it's better to take a little bit more time because, you know, when you look back, like no one's complaining that the merge took too long. We're all like, what about the merge? It's old news, you know? So let's just have a little bit more confidence, as close as 100% we can be. Like every time we do a release, we say, do we have the highest confidence we can have on this? And if not, let's take a little bit more time to look at the data, a little bit more time to analyze, to soak this, to try to break it so we can catch the bug before it's out there and actually impacting users.
I can talk more on the research angle, right? I think this is like a feature and a bug because like social coordination is very expensive on the Ethereum level, right? It's like we like to argue about nothing typically.
No, we don't.
But like between the researchers, the implementers, and different and just in different forums, right? But then we can also speed things up. It's very easy. We can say, okay, this is a topic we made decision just 1 week from now, right? And that's it, right? But that kind of just becomes like a company, right? And one of Ethereum's strength is this decentralization governance, is this raw governance. But the downside of that is it takes a very long time, right? Versus like you go to another approach, which is more top-down, like company style, we can make decisions much faster, right? So it's kind of the trade-off here. And then Ethereum kind of prefer the later approach.
Okay, very quickly, because I have another big question related to this. But very quickly, percentage-wise, right now, how confident are you that Dencun is going to go off without a hitch? There's not going to be any problems and issues. March 13th.
Okay, that's a tough one. I would say we feel really, really good. As close to 100% as we can be. I mean, we've had a lot of testing and even making changes as much as a couple weeks ago to just say, you know what, if we do this, we may not need it, but just having it's going to be a little bit better. So I'm feeling really, really confident. If it was tomorrow, I would be sleeping tonight very well. I'd be excited. I'm not nervous at all. Very similar to the merge. Terence said 99.9%, I think. And I feel really good about this next upgrade. I'm just excited for it to happen. I feel good about it.
So there are also a lot of dependency, right? We can be 100%, but Ethereum right now, if you look at the stack, there's multiple layers, right? There's CL client, there's EL client, there's MEV boost, there's relayer, there's builder, there's searcher, there's blah, 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 right? Like today, if one of the relayer doesn't work, then we're kind of screwed. If today one of the builder doesn't work, we're also kind of screwed, right? So you kind of have this dependency as well, which is kind of beautiful, I guess. But then again, there are a lot of surface for risk, and we're trying to reduce the surface.
That's fair. There are an increasing number of dependencies since the merge for all these other softwares and protocols that need to be upgraded as you upgrade your execution layer client, and that does introduce more risks. Okay. Okay, so one final big question. Unfortunately, we're not going to get time to talk about Electra like I thought, but we'll have another panel for that another time. Big question about the future roadmap of Ethereum. So the merge was supposed to be the last phase of development. And now with Protodanksharding, I don't know if you guys know this, but Protodanksharding is proto. It is like one stepping stone to full danksharding. So there's more upgrades that need to happen to even get the full vision of what we're talking about to reduce fees for L2s. And aside from that, there's just a ton of other development items, Verkle, MaxDB, inclusionless, Enshrine PBS. It seems like a never-ending list of upgrades that need to happen on Ethereum. And I'm wondering if this worries you. I'm wondering if you guys think that this constant pattern of more upgrades is actually a major centralization risk for Ethereum. The fact that Ethereum can upgrade so easily, so quickly, node operators don't ever kind of hard fork away from Ethereum and the release that the client teams are putting out. This seems like a norm and a vision for Ethereum that's not going to be changing anytime soon. How concerned are you guys about the increasing complexity that comes with all these upgrades, the increasing centralization and resources that comes with having to upgrade like twice every year?
My short answer is software is never finished. And Ethereum core protocol, for example, will be continually making, even if you said it's feature complete and we're not adding more features, there's still maintenance stuff to do. And this year in Electra, like the Prism team's point of view on scoping it is, let's pay some of this tech debt down and kind of simplify things, and then we'll go back to the more complex ideas in the following fork. Terence, what do you think?
I'm not concerned at all. I mean, Ethereum works as of today, right? If today say, if everyone goes away, Ethereum will keep working. We have great client diversity. We set up a really good foundation, right? Right now, we just keep adding features on top that we wouldn't have, right? And then I think we have accomplished what we wanted to accomplish, which was the merge, and now we have some sort of data sharding, right? And we can just keep building on top. But yes, there's a lot to do, but I don't feel like we're pressured to do this like tomorrow, basically.
And so you guys aren't worried that one of these upgrades is going to break Ethereum?
Go ahead.
No, because there's client diversity. That's the only reason I don't worry about it. There's enough like people at different geographic location. There's different software stack and stuff like that. If one of the bug goes down, unless it's like a really crazy spec bug that's open source, which everyone can view, then like most of the clients will still survive.
Yeah, same answer for me. It would have to be something fundamentally wrong with the specification, not really in a particular client because of the client diversity model, the multi-client model.
Right. Well, thank you guys. Thank you guys so much for chatting with me about the Dencun upgrade. I hope this was helpful for people in the audience too. If you're a node operator, please update your nodes before March 13th. And yeah, thanks for listening.
Thank you.
Thanks.
All right, so good news. We still have some time, so we can dig a little bit more and and jump on other topics. I think your mic is off, but it will be on.
Sorry, guys. Yeah, the timer.
We're back.
I thought we were going overtime, but I guess we have more time. So maybe we do actually have time to talk about Electra a little bit. So okay,
Yes.
Maybe we should talk about Electra. Let's talk about Electra, because we talked about Dencun, no, please don't go. Let's talk about Electra, because we just talked about Dencun. One of the most controversial things that have been brought up for Electra is obviously reducing staking rewards. Would you agree, or would you say that there's other more controversial things?
That one is, I feel, very controversial. I don't know if it's the most controversial, but when you're looking at that, reducing the validator rewards, right? What is the problem we're trying to solve? It's this growth of validators, right? We're trying to say, let's disincentivize it a little bit to maintain this growth. I think the controversial part is that this won't fix it at all. I mean, it might help a little bit, but you're still going to have the same problems because you still have other incentives. You have block fees, rewards, restaking, these other kind of things. I would even go to say that if you set block reward or validator rewards to near zero, you're still going to have growth, almost at least a little bit. Maybe not on like the institutional side. People are not going to be very interested in 0% or 1% APY. But like at home staker, when I saw that, I was like, whatever, I'm still going to stake. Like, and if I get more ETH, I'm going to put more in there. There's still yield. I'm still going to do it.
This is true.
Is this about the issuance curve?
Yeah, this is about the reducing.
Oh man, this is okay. So I agree. I think we cannot live in a world where 100% ETH is stake. I think everyone agrees with that. I think 25 right now the issuance curve is target 25%. My opinion is that's probably too low. I think there is a middle ground that where everyone's happy. I don't know what the number is. Maybe it's 50% or something like that. But I do agree that like we need to do something. Okay. So this is my only worry is that say today we ship something at 2024 and we don't touch the issuance curve. Okay. And then the next hard fork say delayed like always. It's supposed to be 2025, but we delay until 2026. And that's basically 2 years of doing nothing, right? And at that point, the worst case scenario, we could be looking at 60% of each stake, right? And that's gonna be painful to fix between when you look at 60% each stake, and then you have to kind of like make people add it down to 50%, or you're happy with 60%. So it's kind of weird timing, but I do think 25% is probably a little bit too aggressive.
Okay, but question about that. Why is it that the staking rate being high, like say 100%, is bad if the staking is not done through like if you had enshrined liquid staking or if you had enshrined, I don't know, restaking.
Yeah, but
isn't the reason why like a high staking rate, isn't the reason why it's bad is because most of that staking is happening through like a smart contract. So the smart contract risk is bad, but if you were to address the smart contract risk, would a high staking rate be fine?
I think that's probably fine as long as it doesn't go through like STETH or RETH because now your majority of it is controlled through Lido governance, right? But then if today you have some enshrined staking, which I haven't really heard like a really good proposal there, I think that would take much longer to enshrine like your staking onto Ethereum. But maybe, yes, but like you said, maybe that's okay.
Yeah, it just seems impossible to me to stop innovation on the smart contract level without thinking of a way to enshrine these procedures, these like abilities. But you're right, it is a very complex upgrade. But speaking to addressing the growth of the validator set, another very important code change is maximum effective balance. Why in the world is that not a higher priority for Electra? I'm confused because I thought that could literally break like the networking layer of Ethereum. And the kind of band-aid solution we have in Dencun, reminder, on Dencun, we've got a max churn limit of 8, so woohoo for that. But apparently, that's not going to stop the growth really all that much, especially if that maximum churn limit keeps getting hit. So why is not max EB the top of the list for Electra?
From the client developer perspective, MaxEB is one of the more invasive changes in client implementation. It has a lot of complexity. We can do it in Electra. The argument we're making is if you want to ship something this year, we're not going to do MaxEB. And we're suggesting, as I said earlier, let's simplify things and pay some of this tech debt and then start bringing in the complex changes because it's hard to do both at the same time. And it's also hard to ship and upgrade with a lot of different changes because there are a lot of things to test and there could be gaps perhaps. It's just harder to deal with. I do think MaxEB is a really great idea. I think that's something that people have been wanting for a while, right? Like this concept that you deposit 32 ETH and you're earning yield, but you're only earning yield on the original principal and not the the yield that you've made, that's just driven more and more adoption towards liquid staking, where people are like, well, if I just put that in there, it's just compounding over and over again. And for the average user, they don't have many multiples of 32 ETH. So that's an avenue they've taken. But I think it just boils down to complexity and shipping on time, because I can imagine we say, yeah, let's do it. And then we're hearing, when's Electra going to ship? Stop delaying it. Let's go. But if it's really complex, it's going to be hard to do that.
I think the problem today is that, okay, so before, say today, the merge, there is a headline, then withdraw, there is a headline, and there's Protodankdencunsharding EIP 4844 was the headline, right? But if you look at Electra or Petra, like what is the headline? This is the first time in the Ethereum history where we have a hard fork, but we don't have a headline, right? But because we don't have a headline, then people start like wondering what feature do we ship or what timeline do we base on, right? So now we have to ask our question, do we determine the future based on the timeline, or do we determine the timeline based on the future, right? And really, no one has answered that today. I think that's the first thing we need to decide as a community, right? And then from our end, we have always promoted that we want the timeline to be fixed, that's 2024, and based on the timeline, we decide the future. But then, like, say if today we agree the timeline is on 2025, then yes, we can ship Max EB. We're very happy with Max EB, but we just don't have a timeline in mind.
Okay, that's a very good point. But already developers seem to be thinking that the headline feature for Electra is inclusion lists. It seems as though inclusion lists are the big feature that's going to be going into the next upgrade. And I'm a little bit confused because I don't even think inclusion lists are going to be that helpful for censorship resistance on Ethereum, which we can get into. But I personally am not confident that Electra is going to happen before the end of the year. And so I'm wondering if your team is again in the minority about pushing for a timeline and a type of upgrade that is focused on reducing technical debt, but decisions are being made on these calls, on these ACD calls, where we're including upgrades like inclusion lists that are complex and are not necessarily reducing technical debt, but increasing complexity. I mean, what are your thoughts, Terence?
Yeah, so I think the whole idea with this timeline is that we really wanted to ship Vertical. So Vertical was supposed to be this next big thing, right? And then the question is, okay, Vertical will be delayed for 2025. That is Osaka, right? Now, do we do something in the middle or not? So if we want to do something in the middle, then that middle something has to be small enough such that it has to be the midpoint between now and then Osaka, right? Because if we make it too close to Osaka, then Osaka will be delayed, and then the Vertical will be delayed. So we're pushing Vertical apart. So that was kind of like basically like how everything was decided. But then again, like, I'm just the only person speaking, like, yeah, I'm just speaking, like, there's so many opinions out there. Like, at the end of the day, it's gonna be like community decision, and I do hope we'll reach to the decision very soon.
Anything to add there, Preston?
Nope.
Okay. Yeah. Well, okay, the other thing about Electra, but also broadly about the way that these upgrades, and especially the Dencun upgrade, other parts of it. A big feature that we're talking about, that developers talked about on today's developer call, was account abstraction. And basically code changes that are going to impact the end user and also dApp developers. So in Dencun, actually, there's a couple of upgrades that are going to improve, the smart contract developer experience, like transient storage that has been championed for several years, the deprecation of self-destruct. These are always minor code changes that are a little bit hard to get into upgrades and kind of tacked on. Have you guys thought a little bit about prioritizing like the smart contract developer experience for certain upgrades? Like, I've always seen the main feature being the merge, like 4844, and it seems as though as Ethereum focuses more on being a DA layer, these code changes that are focused on making Ethereum a good execution layer are starting to really, the wind in their sails is lessening. And I worry that, things like EOF, improving the solidity language, improving the EVM, all of these code changes that are more focused on users, on the developers on Ethereum, they're not going to they're not going to headline an upgrade. Is that concerning to you, or do you guys want developers to leave Ethereum? Is that really the goal here? I mean,
Definitely don't want developers to leave Ethereum, and I hear you on some of these pain points here. In my personal opinion, some of the things you listed are on the tech debt side of things, like state expiry and deprecating self-destruct. I think we should, really be focusing on these things, but it's also hard because we have a lot of like alt L1s that are like, oh, we're going to ship the feature faster, and they have the advantage of not having this tech debt with them. So it's kind of this like balance of how do we move fast and have new features and stay competitive, but also like take care of the mess that we're leaving behind from like maybe just poor design or things that are no longer relevant anymore.
So I think a caveat is Preston and I are mostly on consensus layer, so we cannot speak so much on the execution side. But from the consensus side, we actually have been trying to make the developer easier. For example, we are exposing the beacon root onto the EVM that helps eigenlayer with the restaking, helps Rocky Pool. And then for the Electra, we also have this execution layer trigger withdraw that also helps eigenlayer and staking pool. So we're trying to make the dApps easier, but there's not much we can do because we mostly focus on the consensus layer. Yeah.
Yeah, I mean, I feel like in the upgrade, there's competing visions of what Ethereum should be. Like, there's certain upgrades, certain code changes that will really help keep the developer dApp ecosystem on Ethereum strong, and others that will push, encourage users and dApps to move to other protocols like the L2s. But, Ethereum's trying to do both, compete on both, maintain both, improve on some. And I can see why there's lots of competing priorities. Okay, in the last couple seconds that we have, assuming that Electra happens in 2025, not saying that it will, but just potentially if it happens in 2025, what is like the main code change that you would like to see in Electra?
Well, if we're confident that it's not happening this year, it'll happen in 2025, and that we're happy with it happening anytime in the year, I think we can open up the scope a little bit and reconsider, at least from our point of view. You said we're kind of in the minority of saying let's keep it small, but if it's not going to be in the midterm before Osaka, then let's go ahead and do these things like MaxEB inclusion list. ePBS is really exciting as well. I know that Terence has a lot input on that.
All of them?
Well, if we're talking about, we have nearly 2 years from today, or say conservatively like 18 months. I think that's a little bit easier to try to get more stuff and reevaluate the scope. I think that the scope that we initially said was as small as possible, right? Keep the things in there so we could ship something this year like November, December. But if we're saying, well, let's do November, December of the following year, then that's an entire another year of development. So I would say that we could try to get those things in there because they are all nice features and we do want them. But as Terence said, it's like a little bit of a timing thing. Like, do you want it all or do you want it now? Like, you can't have both.
Do you have one, Terence, or are you also similarly thinking like, if it's not going to happen in 2024, then why not just do it like all of them and delay Verkle even further?
Yeah, I mean, this is also like has to do with the EL side planning with the vertical planning, right? I mean, ideally, yes, if we do everything in 2025, we can squeeze in a lot more things because when you have 2 hard fork, it usually means longer time than just 1 hard fork because you have to upgrade 3 test nets and then mainnet, right? And then there's about 2-3 weeks between each test net. So those time are kind of just idle. I guess it's not idle, but you can focus on other things. But yes, it is. I guess you can squeeze in a lot more features with just 1 hard fork.
All right. Okay. Yeah. Well, thank you guys for sticking around for the second half of this talk on Electra. We hope that was helpful, and thank you guys for sticking around. And thank you, Terence and Preston, for the insight on the next Ethereum upgrade.
Yeah. Thank you.
Thank you.
Yes, let's hear it for our great panelists. Thank you, Christine. And we'll have a little break before the next. Yeah, I think we have another few minutes. Yeah, starting in 5. Perfect. Oh, in 20? Oh, yeah. Starting in 20. Thank you.